just this and we bring in those pieces and we will see all the samples of all the assembly.
SUINK contributes to greener electronics and support European transitions towards sustainable and smart digital technologies. Flexible electronics are lightweight, thin, and allow us to integrate the electronic directly in the surfaces, such as plastics, composites, or textiles. Sustainability is assessed across the entire life cycle of the solutions. SUINK applies eco-design principles, reduce or eliminate the critical raw materials, and we apply recycling strategies for the plastics and the integrated electronics.
Recycling is very important today, and it's important to look at it at the very beginning of the project. Especially in the case of SUINK, it is very relevant because it's our very complex materials. We combine new bio-based polymers, but we also add electronics, printed electronics, all sorts of components to it, and that creates a complexity. And then the question is, how will we recycle this at the end? So we look at a lot of different recycling strategies. So the cheapest of them is thermomechanical recycling. Then a second type of recycling is solvatation. In solvatation, we dissolve the whole system with everything in there, and then in separate steps, we try to get all the separate components from it. This can be metallic particles, this can be different grades of polymers. And a last recycling strategy is solvolysis, and there we destroy actually the polymer into its monomer blocks. And the big advantage of this strategy is that we can use the monomers again to synthesize a new biopolymer that has again all the virgin strength and very high qualities that we desire also from recycled polymers.
We are developing the exploitation strategies of the project. We discuss with the consortium the intellectual property strategies and also go-to-market strategies and business models and market positioning. So our goal is to move from research level results to market impact. Since the SUINK solution is flexible and lightweight and sustainable, we are targeting a wide range of applications in the future, and that's what makes it innovative.
The concept here developed in SUINK will be exploited beyond automotive fields. In other application fields like sport and leisure and biomedical, where the monitoring of the body strain can foster the optimization of the performances. Mostly in general, this concept could be exploited in all those industrial fields that are embraced by Internet of Things.
Flexible and hybrid electronics have the capabilities of bringing functionalities, antennas, HMI components to a lot of surfaces and components that are difficult to access. However, this still has some kind of limitations due to the need of powering up or having some kind of intercommunication system required. The SUINK project helps us surpass this limitation by making us able to power up these kind of components in areas which are difficult to access, both in automotive and outside of automotive. Cooperation between the whole SUINK partners has been crucial from the start, and it has helped us make sure that the devices and the systems and the technologies that we are developing are up to automotive standards from the initial stage of the project.
In the SUINK project, there were very strong cooperation between the different players of the supply chain. GEMET in general operates like a link between the early research and the application of the emerging technologies at the industrial level.
Such projects help to bridge the gap between research and industry, because industry can get access to earlier stages of research, and research can get access to end users. Research can be a heavy burden even for large companies, because you need skilled researchers and expensive equipment. So such projects help industries to get access and lower the risk during the path to new applications. One key aspect is to continue collaboration, seeking for new financing.